Hello everyone, welcome to our presentation on intelligent traffic analysis and violation detection system. Urban traffic management in India faces massive challenges: congestion, violations and inefficient monitoring. Today we are going to show how our computer vision and artificial intelligence can revolutionize the way we manage traffic at intersections. Let's dive in. Let's start by understanding the problem. First, most traffic signals operate on fixed timers. Whether there are 5 cars or 50 cars waiting, the signal pointing timings remains the same. This leads to unnecessary delays and congestion. Second, manual monitoring is inefficient. Traffic police cannot be at every intersection 24 by 7, and manual observation misses a lot of violations. Third, traffic violations like red light jumping and rash driving often go undetected and unpunished, creating safety hazards. And finally, there is no data without real time analytics. Traffic management decisions are based on our guesswork rather than facts. Our solution addresses all of these challenges. So what's our solution? We've built an AI-powered computer vision system with 4 capabilities. 1. Vehicle detection using YOLO V8, a state-of-the-art deep learning model that can identify cars, bikes, buses, trucks and auto rickshaws in real time. 2. Multi-object tracking with deep sort. This does not just detect the vehicles frame by frame, it tracks each vehicle consistently across the entire video, giving each one an unique ID. 3. Queue analytics. We measure both queue length and density in real time, providing actionable data for traffic optimization. And 4. Automated violation detection, identifying red light jumps and rash driving without any manual intervention. Now let's look at how the system works. The pipeline has 6 stages. We start with traffic video footage from the camera mounted at the intersection. This footage goes through the YOLO V8 detection model, which processes each frame and identifies all vehicles with bounding boxes. The tracking module then assigns the consistent ID to each vehicle and follows them across the frames, even when they are temporarily hidden behind the other vehicles. Next, the analytics engine calculates the queue length and density by counting the vehicles in the region at the interest before the traffic signal simultaneously. The violation detection module checks for the rule-breaking behavior like crossing the stop line during the red signal. Finally, everything is visualized in the StreamRead dashboard with annotated videos, real-time metrics and violation logs. All of this is powered by OpenCV, Python and industry standard computer vision libraries. Let me explain the detection and tracking components in more detail. For vehicle detection, we use YOLO V8, which stands for You Only Look Once version 8. It is a real-time object detection model that can process video frames incredibly fast. The model was pre-trained on thousands of images, so it already knows what cars, bikes, buses and other vehicles look like. It can detect multiple vehicle types simultaneously, crucial for Indian traffic where you have everything from motorcycles to heavy trucks on the same road. But detection alone isn't enough. We need tracking. Here is why. Imagine a car moving through the intersection. Detection would see it in flame 1, then flame 2, then flame 3. But it doesn't know these are all the same car. That's where the tracking comes in. DeepSort gives each vehicle a unique ID that maintains it throughout a video. It handles occlusions when vehicles temporarily hide behind each other and records complete trajectories. This is essential for violation detection because we need to know where each specific vehicle has been. One of the most practical features is queue analytics system. Queue length estimation is straightforward. We define a region of interest, basically a box, on the road before the traffic signal. Then we simply count how many vehicles in the box at the given time. As the signal changes, we track how the queue grows or shrinks. Queue density goes a step further. We calculate the vehicles per square meter. This tells us how many vehicles are waiting, how much packed they are. High density means severe congestion. For example, at peak hours, we might see 18 vehicles in our region with a density 0.15 vehicles per square meter. This kind of data is gold for traffic management. It can inform decisions about signal timing, identify problem intersections and help with high long length urban planning. Now for the enforcement Aspect automated violation detection red light jump detection works like this. We will define a virtual stop line on the video. The system monitors the signal status red or green. When the signal is red, if any tracked vehicle crosses the stop line, boom, violation detected. The system captures the vehicle ID, a timestamp, and a screenshot as a evidence. Rash driving detection is more sophisticated. We analyze the trajectories we tracked earlier. If the vehicle makes a sudden sharp lane changes, if it's moving too fast in a congested zone, or if it shows erratic zigzag pattern, the system flags it. The key advantage here is consistency. The system never gets tired, never looks away, and never shows bias. Every violation is logged with concrete evidence. All of this data goes to comprehensive violation log with vehicle IDs, violation types, timestamps, and virtual proof. All of this analysis needs to be presented in a user-friendly way. Our Streamlit dashboards provides everything in one place. You can watch the annotated video with the bounding boxes and IDs overlay. Real-time metrics show the current queue length, density, and violation cost. Analytics graphs displays trends over a time, and a searchable violation logs provides all the evidence you need for enforcement. So what's the real impact? For traffic management, this provides the data needed to optimize signal timings based on the actual traffic patterns, not guessworks. Reduce waiting time, improve flow. For law enforcement, it means automated 24/7 monitoring with evidence-based prosecution. No more relying on the manual observation or client compliance. And for urban planning, this generates the long-term data needed to make informed infrastructure decisions. Which intersections need redesign? Where should we add lanes? This data tells us the story. This is exactly the kind of system that smart cities needed. Let me wrap this up with our key takeaways. Computer vision enables automatic traffic analysis at a scale. What used to require the dozens of traffic police can now be done by using cameras and algorithms. Multi-object tracking is critical for understanding vehicle behavior over time, not just detecting them in individual frame. Q Analytics provides the actionable data for optimization. Real numbers, not guesswork. Automated violation detection supports the evidence-based enforcement, creating safer roads. And our modular system design means you can deploy incrementally, start with one intersection, prove the value, then scale. We are building the systems that see, track, and reason, making our roads safer and smarter.
Thank you